Okay, we're doing probability, right? What's the probability those pearls would melt if I put them in vinegar? Well, it's supposed to. What if they're fake pearls? Well, then I didn't tell you the whole story, and you can't really, do the probability for this. Could we do an experimental probability? I want to review all the probability we've done so far. How would we do it with an experiment? Well, you'd actually just go and throw the pearls in, see if they actually melt. If you just do it once, it probably wouldn't be near as good as if you did it 3 or 4 times and you make sure that they actually always melt and it just isn't a certain kind of pearl. All right. That's the difference between theoretical and experimental probability. Theoretically, pearls are supposed to melt. Experimentally, you'd actually do it and experiment over and over again. You make sure if it actually works. All right, some other stuff I want to review with you. Probability is what you want over what's possible. Which changes when I add conditions? Conditional probability. Which of these two change when I add conditions? Like, given that I'm only going to pick a girl, yes, it's possible. The bottom part changes as soon as I say given. All right, so I'm going to give you a chart. Let's see if you remember how to do this. Boy, girl, we'll keep it simple, really simple. Boy, girl. Let's say in this certain kind of cat, they have males more often than females. 53 to 47. Then, given that one of them comes out to be a male, what's the probability that they will both be boys? Given that one of them is for sure a boy. I didn't say the first one. I said one of them is for sure a boy. What's the probability they're both boys? You've got 4 things to draw from. You pick the right ones, and hopefully you know what to do with them. This is a review problem, so I'm not showing you how to do it. I want you to try it. Use your calculator. Get a decimal. And I'm going to pair you with somebody, and you'll see if you get the same answer as them. I'll pause for a second while I do that. Okay, here's how we should have done that. First of all, if I say given, which I did, then right away I know my bottom of my fraction, the things that are possible, isn't 1 anymore. If all things were possible, do you remember that these would all add up to 1? And if they were all possible, I'd have it divided by 1, which means I wouldn't even really have to divide anything. I would just take what I wanted, which was this one, 2 boys. Why couldn't it just be that? Why couldn't it just be 0.2809? Because that would be if all things were possible. And I said, given that there's a boy. Well, if there is a boy, it has to be this one, or this one. It cannot be that one. Okay, so then I have to add those 3 up, or even smarter. Remember how to do this even smarter than adding up those 3? Go 1 minus the 0.2207. 2209. Okay, I'm sorry, say that again. No, I did not say that. I know you might have thought I said that. I even tried to clarify that to make it sure it was clear. I didn't say that the first one was a boy. I said there was a boy. Did you guys hear me say that? Okay, I was making sure not losing my mind here. We can go to the tape because I am recording this, but we'll have to do it later. All right, so anyway, I meant to say, if I didn't, I'm 98% sure I did, that one of them was a boy, not necessarily the first one. So, if one of them was a boy, those 3 get added up, which is the same as 1 minus 2209. Do you get that? That's really important. See, if these, we're going to get into ones where we have huge number of things to add up, and you've got to get smart about this and not actually add them all up. You want to take 1 minus this one because it's a way faster way to get the same thing. Okay, so we have 2809 divided by 1 minus 2209. What was the answer for that when you got that? I haven't actually divided them yet. 7791, anybody verify that? 7791? Okay. All right. What does that mean? It's about a 78% chance that that would happen. Oh, I'm getting some people that disagree now. Yes? thank you. The bottom number is what he was saying. So then I should have done it myself. So I got 2809. I just hate to take the time for this, but sometimes it's actually faster. Divided by, I'm just going to put in parentheses, 1 minus 2209. And 3605. Did you get that? Okay. For the final answer. Okay. Now, usually, how many decimal places do we round to? 3. So, 0.361. Why can't I just use 360? Because that next number is a 5. Anything 5 or bigger tells me to round up. The answer is 361. Okay. There. There's about a 36% chance. Why is that higher than the 28% chance in the first place? 28% chance, or 28.1% chance, would have been if all things were possible. And since we knew there was a boy, obviously the chances that it's boy, boy go up. So from 28 to 36, it makes some sense if you just think about it. Okay, that 77 was not going to make any sense at all. But I didn't understand what we were doing there. We were just getting the answer for the bottom before the 77. Okay, so that's just a review quick of the harder kinds of problems that we were doing at the end of the little unit there. Today is about Venn diagrams. And to start with, I need you to understand mutually exclusive events. You're either a freshman or you're a sophomore. Now, I found in the real world, there's a lot of gray in the real world. How could you be a freshman and a sophomore at the same time? Expand your mind a little bit. What? In the summertime, yeah, it's a gray area. Are you a freshman or a sophomore? You know, you haven't ever actually done anything in the sophomore year. So, of course, a lot of people like to think of themselves as a sophomore since they've graduated their freshman year. Right? So, but that's a good point, gray area. I'll give you one I experienced this year that I haven't experienced before. We have a kid from Germany staying with us. She's a junior here, but she's a sophomore in Germany. So it's like, you know, which one is she? Well, it depends on which country you judge by. When she comes here, this year won't count for her in her German schooling. She has to go back and then do her junior year over again. So is she really a junior? Well, it's kind of a gray area. Could you have kids that might have so many credits coming into high school that they could be a freshman, but yet beyond freshman, sort of? Same thing happens in college. We're talking, you know, freshman and sophomore. This could be in college. What if you go into freshman year with enough credits to technically be a sophomore, but you're a freshman because you're the first year there? So anyway, all I'm trying to say is we try to make things black and white for the simple cases, but you always get that there's weird things where they overlap, and you're kind of both. But there are such things as mutually exclusive events, and they are, you know, either it's above 0 or it's below 0. What if it is 0? Even there you have a case where it's tough to get those to be for sure no overlap. And that's why we do these Venn diagrams, because most things in the real world have overlap. I mean, do you have to be a dog person or a cat person? What if you like both? That's where they overlap. All right. So basically, these things are really handy for doing probability problems. I did one on a practice SAT test just the other day. They were saying, you know, this many people play the piano, this many people play flute. What's the least number of people that could play both? And we needed a Venn diagram to figure it out. So, all right, let's talk about this. Kids who have brown hair, kids who have dogs, or of course you could be neither. You're in one of those categories. Let's just figure out. Now, you get to judge for yourself whether your hair is blonde or brown or whatever, okay? My hair is pretty close to black, but a lot of people would say it's dark brown. Oh, okay. On yours it says iPod? All right. So I'm going to stick with brown hair and dog because iPod, old school, not many people even have iPods anymore because almost everybody goes with the phone nowadays. It was literally made 4 years ago. And not many people had iPhones yet. Now it's like ubiquitous. Okay, so back to the brown hair dog thing. So even though yours will say iPod, you can change it to brown hair. How many of you in here would identify yourself as a brown-haired person but not having a dog? That would be these people right here. You have brown hair, but you do not have a dog. 1, 2, 3, 4, 5 of you. Okay. How many of you have brown hair and have a dog? 1, 2, 3, 4, 5, 6, 7, 8. How many of you have a dog but not brown hair? 1, 2, 3, 4, 5, 6, 7. How many of you don't fit into either the brown hair or the dog categories? You're in neither. 1, 2, 3. All right. So now you see how these are all developed. Now notice this is grand total up here. I recommend, I really do, it helps a lot because you're doing probabilities, which is out of the total usually. It's really smart to add them all up. So let's add it this way. That's 10, and that's 13, so total makes 23. I think there's more than 23 of you. I guess I do have a bunch of people absent today. So, okay. So then, what's the probability that if I pick a kid, that I will get a kid with brown hair? Now, just clear here. Brown hair does not mean the 5. If I get a kid that has brown hair, do you get that's 5 plus the 8? I win if I get one of these kids or one of these kids. They both have brown hair. I didn't say anything about a dog. You know what I'm saying? So it's this or this, 5 or 8. So 5 or 8 out of 5 plus 8. See, or means like add. 5 plus the 8 out of 23. Does that make sense to you? Okay, now what's the probability that I get a person who has a dog? Person who has a dog. Write it on your iPad. Turn it my way. It's a fraction. You can actually add the top if you want. Yes, 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 yes. Wait a minute, I think you answered a different question. Yes, I just asked the probability I pick a kid who has a dog. Yes, 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 yes. Okay, good. Everybody's getting it right. Awesome. 15 out of 23, these two put together. All right, notice those two spots are both people with dogs. If I said there are 10 people with dogs and you're creating this chart, a lot of people will just slap the 10 right in here. But the two things together make 10. That's what makes it a little more complicated. This area and that area is the area where you have dogs. Okay, then let's do this thing underneath here, probability then. And again, it says iPod, so you just change it to brown here. Now, how do I get these probabilities? Well, I still have a grand total of 23. That goes here. But now these are going to be decimals. Instead of having the 5 here, I have the 5 out of 23. That means there's a 5 in 23 chance that I take my total, that if I pick a kid at random, that I'm going to get a kid that has brown hair and does not have a dog. That's what that little spot represents. So when you actually divide it out, you usually put decimals in here. We usually round those decimals to 3 decimal places, even though I know that's rounding in the middle of the problem. 5 divided by 23. You know what? Let's put 4 decimal places just so we're a little more accurate. 2173. Oh, and the 3 should round up to a 4 if we're going to go to that spot. You're right. All right, the middle one, it's simply 8 out of 23. I think you're getting the idea how these come about. 3, 4, 7, 8. Etc. Now think about this. What do you think every probability on the chart adds up to? 1, 100%. And do you think there's a chance it could be off a smidge? And if it's off a smidge, why? Because we're rounding. All right. What's the difference then between a frequency Venn and a probability Venn. The frequency Venn is how frequent was it to have a person with brown hair. Basically, it's the starting numbers. The probability Venn is all the same starting numbers except divided by the total. So in other words, you just got your decimals in here. Now the nice part, if you have the decimals already, you don't have to do any dividing. So if I wanted to say, what's the probability that I get a kid who has brown hair and a dog, I don't have to go divide anything. I already got it. Probability I'm going to pick a kid with brown hair and a dog in this class is about a 35% chance. Okay, so I'm going to try it. Okay, person 7. Person 7. So I'm going to go over to my grade book and see who person 7 is. What is the probability again? I'm going to get a person with brown hair and a dog. 35% chance. So now I want you to think a little deeper. Obviously, I'm not going to for sure get. I'm either going to get one or I'm not going to get one, right? How many guesses do you think it'll take before I get a kid who has brown hair and a dog? What would you expect it to take? One guess? No. Only 35% chance of it, right? Take your best guess on how many people I'm going to randomly pick before I find someone who's got brown hair and a dog. Good question. It is going to be with, you're thinking very deep, but you're right. I'm not going to allow myself to pick the same person twice. All right, so I'm going to pick a bunch of times. And this is just a guess, but what's your expectation? What would you expect? That's called expected value. You're going to officially do this later. But. All right, so person 7 is Mr. K in the front row. Were you a person with brown hair and a dog? All right, so therefore he didn't count. And so therefore no, nobody yet. I'm going to go with person 13. Person 13 is a person who's absent. That doesn't count, I don't think. I'm going to go to 14 then because the person's absent. Mr. N. Brown hair and a dog. Took 2 guesses. How many of you guessed it would take 2 times? Okay. How many guessed it would take 3 times? That's kind of where I was assuming. Does that mean you were all dumb? No. It was just I got a little more lucky than I expected to get. Could it have taken me 5 times? Of course. And what you can actually do is figure out the probability that I get, it on the first guess, on the second guess, on the third guess, on the fourth guess. We'll talk more about that later. All right. Now take cats versus dog, except this time I'm going to just take data for you, and then you're going to answer a bunch of questions about it. Okay? So, how many of you have a cat? No, wait, I should clarify. How many of you just have a cat? Cat, but not a dog. 1, 2, 3 people. How many of you have a cat and a dog? 1, 2 people. How many of you have a dog, at least, but no cats? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And just to clarify, how many neithers do we have? No cats, no dogs. 1, 2, 3, 4, 5. Okay, add them all up. I'll make sure it adds up to the right thing. It does. It adds up to 23, and notice I put that right there. Now I'm going to ask you a few questions, probability-wise, and I'm going to do some givens, too, and we'll see if you're smart enough to figure out how that changes the denominator, changes what it's out of. Okay? What's the probability, if I pick a random kid, that they're going to have a cat? Write it on your iPad. They're going to have a cat. Now, would you turn it to the kid I paired you with today and just see if you have the same thing as they do? Don't need to divide it. You can leave it as a fraction. If you haven't divided it, that's fine. Just let them divide it on the calculator so you can compare the same things. For now, let's not even divide these with a calculator and get the decimals. Just save time and write the fraction. One less step. Okay, then, what was that one, by the way? 5 out of 23? Excellent. Okay, now let's move up a step. Probability that I would pick somebody who does not have a dog. Think about what would make you win, and think about what it's out of total, if I made any restrictions on what could happen. Probability I'm going to get somebody that does not have a dog. person sitting next to you. All right. These are the people that did not have a dog. And 5 is the one everybody forgets usually. So 5 and 3 makes 8. 8 out of 23. Okay, good. Next one. Given that I know that this person has a dog, what's the probability that they also have a cat? Given I know I'm going to pick from only people who have dogs, and what's the probability that they will also have a cat? Okay, do you remember how given changes to what it's out of? It is not a 23 anymore. It's only out of people that had dogs. Do you get how I can only use those numbers and I can't use that and I can't use that? That's a really critical thing to know, that you got to cross off the things you can't use, because you by accident a lot of times will grab one of these numbers and put it on top, but you can't. So probability that they have a cat, then I can only pick from the things in here, so that it's got to be 2 out of a total of all the things in here, which was 15. 2 out of 15. Why isn't it out of 23? Because not all of those were possible. The only things that were possible were those 15, because they all had to have dogs. Why didn't I use the 3? Because it isn't in the possible. Those 3 people didn't have dogs in the first place, so they couldn't be picked. That's why I had to do 2 out of the 13. Okay, let's do another one like that. Given that this person does not have a cat, what's the probability if they have a dog? Given that the person does not have a cat, get good at throwing out the things that are not possible. As soon as I said given they did not have a cat, you should have gone like that. You know what I'm saying? All those people had cats, they're all out of the running. Now it's an easy question. You only have 2 numbers. See what I mean? So then, what's the probability that they had a dog? 13. The dogs left out of the numbers I can use. And then the total is add up everything that's left. 13 and the 5 makes 18. 13 out of 8. There's your hand if you had that one right. Okay, good. You guys are tracking me really well. Let's move on. This is just a already done. You know what? This is too easy of a question. You guys are beyond that. You can handle this too easily. All right. This has a little bit more terminology in it, because it has the P parentheses M. That just means probability that you're going to pick an M, which of course would stand for math in this case. Let's see if you stumble into the wrong answer here. Go ahead and try these 2. A goes with the one on the right. I guess it's the same drawing. So probability of M and then probability of S. Let me ask it to you this way. You probably already have your answer, because these are probability Venns. You don't have to divide by anything, unless we say given, but we didn't. Okay, so you can divide by 1, or you can just say the answer. Did you choose both of these, or did you just choose one of them? What do you think is the right way to do it? If you asked, of course, I think it's a no-brainer. This obviously goes with math. The only real question is does that go with probability of M? If you ask those people in the middle there, do you have a math class? What would they say? Yeah, they wouldn't say, no, I have a math and a science class. That'd be obnoxious. You just ask them if they have math. They say yes. That means you include them. You should have included both, 0.7. A common mistake is just to say 0.4. All right, science then would be these 2. Total of 0.5, 50%. All right, moving on. Math and science. Now, do you remember this before? When I said and, like I said, okay, I pick a kid. What's the probability I picked a kid, let's say I pick you, that has a dog? What's the probability he has a dog? Or this, or that, compared to this and this and this. So he has a dog, and he has a Cadillac, and he has a pink flamingo in his front yard. You get how my probability keeps going down? When I say and, your answers get small. See, the common mistake here is to go math and science. I add them all up. No. Math and science means I get a small answer. Kind of counterintuitive. So math and science, if I ask, only these people would say, if I say, do you have a math and science class? Only those kids would say yes. Even though in the real world, in the school, of course, almost everybody's got a math and a science. So this must be a weird school. But, all right, maybe it's like summer camp. How many of you are, or summer homework? How many of you have it for math class? How many have it for science class? How many have it for both? I could see that being more of a distribution like this. All right, so you should have picked that. And did it have any restrictions? Was it any givens? So you don't have to worry about any dividing by anything. What if I had said, given the kid has a science class? Do you get how that and that are not possible now? And then I would have said 0.3 out of 0.5. Okay, good. Now, one more thing. This is an important thing to get. You guys have seen an intersection on a road before, right? You got this road and you got that road. And the intersection, why did they change color? That was weird. I'm using the same marker. What just happened? If I draw one more time, what color do you think it'll be? Whoa. What? If I draw up, down, it's green. If I draw left, right, it's black. This is, my world just changed. What? Oh, you're right. But the fact that I started on the slider bar, but that, what? I've never seen this before in my life. Okay, wow. Thank you for that moment. Okay, so these are two roads. Like you guys know where 7 and 101 intersect, right? This is like 7 outside the school here. Going past the school. Here's like 101 that's going. I'm using actually the different markers this time. 101. And the intersection is where they cross, right? That's technically the intersection of the two roads, right? You've heard of the intersection. All right. Well, this is an intersection. Where you say this and this, that part right there, where they overlap, see, it's just like this, where they overlap, that's the intersection. And this little symbol right here, the upside down U, means intersection. Also, you could say it this way. The upside down U means and. Now remember, those give you small answers. What do you think when you do mean all of them go together? What word is that if you say, if you want all of them? Like, I want all of these to be my probability. You don't use and, what do you use? Or, because or means you add them up, right? So, if I said, what's the probability I'm going to get a kid who has math or science? Then I would add up this, and this. Or means big answers. And the symbol for that is not a intersection like this. It's a U for union. So this means or, and it gives you a big answer. This means intersect, which is like and it means a small answer. U as in union, it makes sense to me to be like a big union, like the Union of the United States of America. It's all of the United States, all of them united together into this big group, okay? The and doesn't make as much sense to me because and has always meant this and this and this, but that's the one that's counterintuitive. The and one is not a whole bunch of things. And is only that one, where they overlap. Okay. So, probability, P, M or S. Remember? Think to yourself, does or mean a big or a small answer? And then figure out what the answer is, and then compare with the kid next to you. Notice there was no given here. Have you already compared? All right. Mr. C, what did you get? what? Yes, I know your last name is not C, but I usually call you C. But anyway, go ahead. I agree. Or means these all together. Another way to think of it is asking these people, do you have math or science? And they'd say, yeah. Do you have math or science? And they'd say, yes. I know technically they could say, no, I have math and science, but they have math or they have science. If I ask them, do you have a dog or a cat? And they'd just say, yeah, I have a dog and a cat, actually. So anyway, all of these work. I can see how a person might think you throw this out, but you don't. You include them all. Okay, so I think we've covered pretty much everything you need to know. This is the official name for this. If they say or, you add them. Okay? Now, what they're doing is probability of A or, this is probability of A only, which is like this, B only, which is like this, and A and B all together. So basically, it means it's saying in a math way that or means you add up all three parts. Okay, your assignment is this. I think it should be easy for you. You're going to like this one. Tomorrow is just makes, basically we add a little bit more complication by having 3 overlapping circles. And the problems get a little more complicated when it comes to the givens. Given this, then what's the probability of that? We do a lot more given stuff tomorrow. Okay? No homework problems being tossed out because it's a pretty easy day. That's all I have for you for today.